Bienvenidos, Ushamdid, and welcome Anne Arundel Community College learners from the Spring 2023 semester taking the CTS-233 Section 400 Network Programmability course. This is the DEVASC 200-901 Certification Exam Preparation course from the Cisco Networking Academy. And in this activity, we're going to be taking a look at Packet Tracer 5.5.7, where we're going to explore some network protocols. And we are going to be looking at a ton of stuff. We're going to be looking at DNS, FTP, SSH, HTTPS. We're going to be configuring email via SMTP and POP and a whole bunch of other stuff. So let's go ahead and dive in and kick this activity off. So if we go over here to Packet Tracer, you can see that the topology that we're dealing with is the almost very same topology that we had earlier that we brought the PCs into. So this is a different Packet Tracer activity, and they've provided the PCs here for PCA and PCB. So again, we're doing DNS, DHCP, NTP, we're doing a whole bunch of stuff. So let's dive in and get this going. We're going to configure a local DNS server on the corporate server. So we're going to click on the corporate server, we're going to click on services, and over on the left-hand side, you can see you've got a menu of services to pick from. We're going to be looking for DNS. So DNS is right there. Now, you can see the DNS service is off, so we're going to go ahead and click the On Radio button, and we're going to go ahead and create an A record here. And basically what an A record is when someone types in the name www.example.com, what's going to happen is a DNS request to resolve that domain name would be sent to this server, presumably, and this server is going to go ahead and resolve that domain name to an IP address, and the IP address is 64.100.0.10, which we know from the previous activity is this server right here, www.example.com. So we put in www.example.com. You can see we're going to leave this as an A record because that's exactly what we're doing here. And we're simply going to click on, oops, sorry. I put the wrong field there. So the name box, or actually, yeah, the name box is example.com. And the address, sorry about that, I got the boxes confused there for a second, 0.10. And so from here, we're going to click on Add. And you can see that we've got the information in here, and there is our A record. So it says you now see an entry down there for example server. So let's configure the test, or configure and test the use of the local DNS server. So we're going to use PCA to do that first, right? So we're going to come to PCA, click on config, and you can see that the DNS server entry would be right here. So here, what we're doing, since we just configured this on the corporate server, right? We're going to refer to that corporate server as our DNS server. So we're going to put in here, we would put 192.168.1.3. Before we do that, and it's interesting, they don't have you do this, but let's do this first. Let's see what happens when we try to ping www.example.com. And you can see that we can't resolve that host name to an IP address, which is what we need. So let's go back to config. Let's finish this up here. We'll say 192.168.1.3. And now we do have a legitimate, valid DNS server in there. And let's go back to our desktop and let's try this again. So we've configured name resolution, or the DNS configuration here on PCB. We're going to let that run. It's going to take at least a couple of timeouts before it works. And so now when we type in www.example.com, the pings are going to work. Now, it's interesting here. You have this note. It says there's a known issue with Packet Tracer's implementation of the firewall. You will not be able to access the web servers from PCA, which is, again, on this inside VLAN interface, because this ASA 5505 and Packet Tracer is... it's kind of kludgy with the ASA firewall. So as you can see, though, we are now able to resolve that host name to an IP address, and we are able to ping. All right, so later in the activity, we're going to use that example server again. Okay, so now we're going to configure and test the use of remote DNS. Now, remember, we just did local DNS, and local DNS is this corporate server is on the same subnet that I am on. If we look at the config, you can see it's 192.1. Get the interface up. It's 192.168.1.3, right? And PCA is 192.168.1. Get the interface up here, 1.2. So that's local. So now we're going to do remote DNS, but here we're going to use PCB, right? And remote is, take a look here. We're going to have to come through this router, and it's kind of simulating this internet connection here. But again, it's internet out this way. Coming this way, we're coming inside from the outside VLAN, trying to reach the DNS server. But we're not going to do the corporate DNS server. We're going to use this www.example.com. So let's click on the desktop first. Let's click the command prompt here, and let's see. Can I ping www.example.com, or do we get a message telling us, hey, I have no idea how to do name resolution? So what are we going to do? We're going to go out to the internet, out to example.com, and you can think of example.com as Google's DNS servers, right? So if you're using 8.8.8.8, you are doing remote DNS. So we're just doing local DNS here. So let's go ahead and configure this up, 64.100.0.10, and that is my DNS server. And so now if I come back to the desktop and I try to ping example.com, you'll notice we don't get the message telling us that the ping request couldn't find the host, www.example.com. It's just going to wait here. And again, we're going to have at least 1 or 2 iterations of pinging before this actually works. So you can see down here the completion percentage is increasing, and we are currently at 14%. So the ping could take a few seconds. It's definitely going to take a few seconds for this to work, and we'll let it do its thing. And while it's doing its thing, we'll continue on here. So then it wants us to ping www.DEVASC, and there you go. The pings worked and came through, -netacad. So it wants us to ping this over here. Well, let's go ahead and let's see what happens when we try to ping www.devasc-netacad.pka. PKA. That would have not ended as we expected. So the ping may not work the first time or even the second time, and that's okay. We'll continue to ping, but we're definitely going to get success here at some point. And then it's going to want us to close the command prompt down. We'll leave it open here for just a second because we're going to pull the web browser up. And again, remember, we are coming from this network here through the internet to get to www.example.com or to get over here to the devasc-netacad. So it didn't work. Let's run it again. And we want to make sure we wait for success here before we close this window down. And it should work here any second now. It's just packet tracer a little bit slow on the uptake. And so we are at step H. And there we go. So now it is working. So now that we know that we can ping it, we're going to pull our web browser up. And in the URL field, we're going to go to www.example.com. And there we go. We're at example.com. And what happens if we go to www.devasc-netacad.pka? And I think I misspelled netacad. There we go. netacad.pka. DevNet Associate. Welcome to the DevASC course. All right, so that's all working. So that was the configuration of local and remote DNS. So now we're going to configure DHCP. And again, DHCP, the Dynamic Host Configuration Protocol, it's all about the automatic assignment or the auto magic assignment of IP addresses to hosts. So we're going to do this on the corporate server. So it's going to be impacting PCA at a minimum. We'll stretch this out. We'll go back to the Services tab, and we're going to click on DHCP, which is right up here at the top. Now, you'll notice DHCP is currently off. We're going to turn it on. We're going to leave the name as server pool. Now, the default gateway, we're going to make the inside interface of the firewall, 192.168.1.1. Now, DNS server, we've seen this before because, again, remember, what we're typing in here, these are the attributes that are going to be provided to hosts requesting DHCP addresses from this DHCP server. And so the DNS, we're simply going to use the corporate server 192.168.1.3. So local DNS here, right? We're not giving it the 64.100.0.10. So we're going to use local DNS here. So we've got that turned on. And 192.168.1.0 has already been dropped in here for us. We can see that. And we can see, oh, I'm sorry, the start address. We want 192.168.1.10. So we're going to reserve those first 10 addresses. And this is always a best practice. So if we were doing this from the CLI on a Cisco router, if we were configuring DHCP, this would be our DHCP IP excluded range, right? We'd have an excluded range that would go from 192.168.1.1 all the way up to 1.9. So the first address and the address that PCA will get when we flip it from a static IP to DHCP is 192.168.1.10. If we had another PC pop in here, it would get 1.11 and then 1.12 and so forth and so on. And again, the subnet mask is already a /24 at the 255.255.255.0. Maximum number of users, we're going to set that to 245 is what I believe they want us to set it to. They do. We don't need TFTP or a wireless LAN controller of any kind. And so at this point, we can go ahead and click Save. And you can see that our server pool has been updated. We've got our default gateway, DNS server, start address, max users, subnet mask, no TFTP or anything else. And so now we are at 29%. So now let's test that DHCP configuration, right? Because we've got it set up. Let's make sure it's working. We're going to come to PCA. And the IP configuration here, it was static, 192.168.1.2/24. We're going to click DHCP, and we're going to get that 10 dot address. Or I should say the 192.168.1.10. You can see we pick up the subnet mask. What about DHCP, right? Or I'm sorry, what about the DNS server? Yeah, it's still picked up here via DHCP, right? So we've got our addressing information here. And you can see that the settings over here, the default gateway and the DNS server, also picked up from DHCP. So 31% on the completion percentage down here, if you're keeping track, for those of you keeping track at home. All right, so now we're going to configure NTP. And NTP is one of the slowest processes to actually start to work. So we're probably going to have some time to move off and do SSH, and then we'll check the NTP. We'll check the NTP setup after we deal with SSH. So let's go ahead and drag this out here. And we're going to drop into the CLI is what they're asking us to do. And actually, before we do that, I jumped to step 2 there. Let's go back to the corporate server. We're still here with services. We want NTP. So we're going to turn NTP on. And we are going to... I think that's all we are doing. We're going to disable authentication, right? So there's not going to be any authentication here. And you can see this is May 20. Let's go ahead and do 21 May 2022. And it's actually February. And it's actually the 26th of February. Oh, I'm sorry, 2023. Holy Toledo, am I a year behind? All right, so 2023, it's the 26th of February. 5:31, it's actually 6. So let's change that. We'll bump that up to 6, and it's 11. So we'll try to get some decent time in here. All right. So we'll leave it as that. So the NTP service is on. So now I want to jump on to switch number 2, and this is going to be pretty straightforward. We're going to go from user exec. We're going to transition into privilege exec. Password is Cisco, all lowercase. We're going to go into global config, and I'm simply going to say NTP. So, and actually, before we do that, they want me to do a do show clock detail. And you can see that the time source is actually the hardware calendar right now. And you see that UTC date there, Monday, March 1st, 1993, that famous date that all of the Cisco devices will show you if they are not using NTP. So if I say do show NTP status, you can see NTP is not enabled. What about do show NTP associations? Again, we don't have any NTP configured here, so nothing is going to work. In fact, that, do show clock detail, again, and the asterisk there shows that, we are definitely out of sync with, it's not accurate time. Okay, so we're in global config here. Now we're going to say NTP server, and the NTP server is 192.168.1.3. It's that corporate server. Now, we might be thinking, okay, great, everything is great here. I'm going to go ahead and say write mem. I'm going to say show clock detail. Yeah, it hasn't synced yet. And NTP, if I say show NTP status, it takes forever. We should see Stratum 2 here and it should say that the clock is synchronized. But again, we'll come back to that because this is I've seen this take as much as 15 minutes in lab environments and production environments with Cisco devices using Cisco devices for NTP servers, right? So it can take a while. So we're going to flip up here to part number 4, and we're going to go back to PCA, and where's PCA? There we go. We're going to go back to PCA here. We're going to go to the desktop, and I'm going to make this a little bit larger so we've got some more real estate with which to work here. And let's pull PCA back up here. All right, so there we go. So we're on the CLI for PCA. So we're going to type in telnet 192.168.1.4. And you can see connection closed, right? Because probably on the VTY lines, we have only SSH enabled, right? So the access method is probably not going to be telnet. And we'll be able to take a look at that on switch 2 when we get logged in. So we have to log in here, but we've got to use SSH to do that. And the reason I paused for speaking there was I've actually myself typoed administrator, if you can believe that, and then started to think that that the password I was typing in wasn't set on the switch, right? That something was wrong because I was typing the right password in. So pay close attention here, especially to this -L. That is a -L, not a -1. And when the CCNA security curriculum was around and I was teaching that, that was the #1 question. And the problem that learners would run into in that course was they would go to run SSH and they'd put SSH -1 in the username. And you're going to get the following error if you put that -1 in here. If you say -1 administrator and then what's the IP? 192.168.1.4 is where we're trying to go. You're going to get that. It's going to say invalid command. And it looks a lot like an L, the 1 does. And that's why they even have a note in the lab. I wish that would have been in the CCNA security labs that we used to do. But it's an L. So when you put the L in there, it's going to work. And now we type in Cisco in all lowercase. And here we are on switch 2. So let's go from user exec to privilege exec. Let's type Cisco in again. That's the enable password. And so from here, I can say show NTP status, right? Because I'm on switch 2. And we are synchronized. And there you go, stratum 2, which is how reliable is the source or how close is the source, so to speak. And the NTP source is 192.168.1.3. What about a show clock detail now? Let's see what we get here. All right, you notice the asterisk here at the beginning is gone because our time is synced up and pretty accurate time, right? We're only a few seconds off there, but we've got the right Sunday, February 26th. And actually, this is UTC time, so I'm I guess it's going to be -4, -5, +4, +5, whatever the case may be. So anyway, I did it to East Coast here, but we're good, right? The NTP is working and the time source is coming from an NTP server, and that's exactly what we were hoping for. All right, so now we're going to dig down into the MIBs, and we're going to be doing this on PCB, right? So SNMP has MIBs, and we can query those MIBs, right, from an SNMP management station, right, like a SolarWinds or, a Tivoli or whatever the case may be, but you can also use these custom MIBs in order to, write programs that could query, right? Like an SNMP agent is something that you could use on the host in order to have it alert when something goes wrong. Like an interface goes down, it can fire off an SNMP alert, right? So we're going to take a look at the MIBs that make all that happen. So here we go on PCB. We're going to says the MIB browser. Sorry, I saw the web browser. I'm like, wait a second, it shouldn't be the web browser. It should be the MIB browser. So here we are. We're going to click on the address field, and we're going to type in over here 172.16.3.1, and we're going to go ahead and click on the Advanced tab. And the Advanced tab is going to pop up. The read community is going to be read, and the write community is going to be write. And we'll see on the, I think it's the router where this is configured, router 3. So we'll look at router 3 here in a second. and I'll show you what's configured there. So this is going to be SNMP v3, and I'm going to click OK. And click the arrow next to the MIB. Okay, so then we get the MIB tree over here on the left-hand side. So we're going to go to the router MIB. We're going to go to, oops, sorry. Am I in the right spot here? Let me double check. Router standard MIBs. Yeah, and we want to continue expanding management. And router standard MIBs. And I think I may have gone, oh, there we go. So there's the dot management. And we want to expand dot management out, which we did. And you can see we get MIB2 and private. And I'm just making sure we cover everything over here. Expand MIB2 out, and you can see there is the system. And so continue expanding the tree all the way to the system. Expand system, and we may need to make this so we can drag this over here and see what's going on. So we'll do that. And you can see system description, right? Well, we can set that on the router. Object ID, the uptime, contact, system name, system location, right? So these are SNMP values that we can configure that would then be sent as an alert, right? Or could be queried from a management station. So it says, get all the way down, click sysname. And so let's get on to system.name, and we're going to click go. And so when we do that, you can see it's going to give us information here all the way down to system name.0, right? And so this is the MIB for the system name. And you will now see the value of the object is router 3, and you can see that right there. Look at the other objects in the MIB, such as the interfaces on the router, so we could expand out those interfaces, and you can see here, interface number, there's an interface table, interface entry, right? So what is the interface index? What's the interface description? What type of interface? What's the MTU? Is it 1400? Is it 1340, right? What's the interface speed? What's the physical address, the MAC address, right? So all of this information can be queried, right, or provided to a management server or management application of some kind. And so we did the interfaces down to the interface table, down to the IF entry, down to the interface operation status. And now let's click go again. And so if you take a look here, right, if we were to query router 3 via SNMP, we would, using these MIBs, we would see that the operational interface, operational status 1 is down for that interface. These other two interfaces are up. So let's pull router 3 up here. Let's confirm what we're seeing, right? Give ourselves some more room here. We'll go into privilege exec, and we're going to say show IP interface brief. So are two interfaces up and one interface down? And that is certainly what it looks like. Two interfaces up and one is administratively down. And that's exactly what we're seeing over here on PCB, taking a look at the MIBs, right? So this is kind of like a little MIB explorer right here for SNMP. All right, so now we're going to move on to part 6 here, where we're going to configure HTTPS. Now, this is pretty easy sailing here. We're going to pull up PCB. We're going to close down our MIB browser. We're going to pull up the web browser. And we're going to try to enter the URL here. And we're going to click go. And it's going to be HTTP. And we should see, I can't remember, I think it's supposed to work here. So we're going to say www.devasc-netacad.pka. I'm going to hit enter, and you can see that this is working. This is great, right? So now we're going to go look at the firewall. And this DEVASC server up here, if I click on that server, and I click on services, and I click on HTTP here at the top, you can see that HTTP is on, but HTTPS is off. So let's keep that in mind. Let's go to the firewall right now, because they want us to take a look at the firewall ACLs. Now remember, we looked at these ACLs before in lab packet tracer 546, right? So let's go from user exec to privilege exec. I believe there's no password, right? Not a good thing on your firewall, but that's the case here. So it's actually better for us because we don't have to type it in. So there is our ACL for outside to DMZ connectivity, right? And we're allowing ping, we're allowing HTTP, and we're allowing HTTPS. The thing is that HTTPS didn't look like it was enabled on the server there. And it's actually going to have us, I'm looking to see, is it going to have us configure that? And it does right here. All right, so here's what we're going to do though. We're going to get into global config, and we're going to say no access list. And so we're going to be removing, and I think it's extended. Oh, that's right. Okay, outside to DMZ, extended, and permit TCP any host 192.168.2.3 equal to www. So all we're doing is we're removing the ACL that's part of this firewall rule outside to DMZ, and we're no longer permitting TCP from anywhere to go to that web server, DEVASC-Netacad, if it's just HTTP, right? We're going to force HTTPS. So we'll say no, and we'll go ahead and click in here, and let's say show run to confirm, and take a look at that, right? So that rule is gone. We're only allowing HTTPS. So if we're going to do that, let's go ahead and come up here to configure HTTPS. And again, this is pretty straightforward. We're going to go to the DEVASC server, and we're just going to click right there. Now, we could also just click off, right? So we could turn HTTP off if we wanted to do that. You know, we'll leave it on, or actually, oh, we got 2 points for that. Okay, I didn't realize that it had you turn it off. Okay, oh, they do. Okay, so turn HTTP off. I didn't even know that. So we can turn HTTP off and turn HTTPS on, and that's been done. So now I should be able to come back over here to PCB, and if I click go, and actually let me close this down, and we're going to reopen it here. So let's open the web browser up again here, and let's go ahead and retype in the HTTP version of the URL, which is www.devasc-netacad.com, or PKA. PKA. I'm going to hit enter, and you see we don't get the web page back, right? Because we're using HTTP. So let's change our scheme here, and let's use HTTPS. And as you can see, it works just as we had hoped it would. All right, so now we're getting to the end here. We've got part 7. We're going to configure, and I'm going to show you how to send email back and forth between PCs. So let's go ahead and jump on example server up here. We're going to give ourselves a little bit more room with which to work, so it's a little bit more visible. We're going to click on services. We're going to go to email. And under email, you can see we've got SMTP and we've got POP3. So let's turn both of those guys on. And we're going to enter in for the domain name here, because this is going to be our email server. So we're going to enter in www.example.com in the domain box, and we're going to click set. All right. So now that we've done that, we need to create some users on our email server here. So the first user, and make sure you're paying attention here, that is a capital S. If you do a lowercase s, you will run into issues with your scoring. So first user is student1. Password is just going to be class. We're going to click the add button. Our first user goes in, and take a look at that. It bumped us up to 56%. Second user is student. Whoops, did I spell that right? S-T-U-D-E-N-T, student2. And the password is also class. And so we add that user. So we've got student1 and student2. Well, now we're going to configure the clients. The email server has been configured, which is example.com. Now we're going to come over here to PCA and PCB. So on PCA, we're going to shut that down, and we're going to pull up the email configuration here. So what is my username here on PCA? So for PCA, it's going to be student1. Email address, and that's a capital S, is student1 at www.example.com. Incoming mail server, we're going to use the IP 64.100.0.10, and then again, 64.100.0.10. Login information, student1, capital S, and then class with a lowercase c. And you can see we're now up to 60% on our scoring over here. And we're going to click on save. So we've just configured PCA to be an email client. And we're going to repeat the configuration on PCB, but we're replacing student 1 with student 2. So we're going to do the same steps. We're going to come over to PCB. We're going to close down the web browser. We're going to open up the email application here. And again, your name is just student 2. Email address is student2 at www.example.com. Incoming mail server 64.100.0.10. Outgoing 64.100.0.10. And the username is student2 and the password is still class. And we'll go ahead and click save. All right. So now we're going to send and receive some email here. And on PCB, since the email client is already open, we're going to click on Compose. And who am I sending the email to? Well, we're going to send it to student1 at www.example.com. And the subject line is email. In the message box, type, how are you? All right, there we go. And then we're going to click on send. And that is it. You can see down here, sending mail to student 1 with subject, whatever, blah, 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 mail server, send success. Okay, great. Well, if that's the case, I should be able to come over here, click on receive, and take a look at that. So you've just learned how to set up an email server here in Packet Tracer. So we're going to open the email up. We've got it. We're going to double click. We're going to click on reply, and we're going to send a message back. And does it have to say anything? And I'm going to say, great. How are you? All right. And then we're going to click on send here. We can go back over and you can see we're now at 90%, right? So that email configuration counted for a ton of points in this activity. So back on PCB, right? Whoever's working on PCB, all right, hey, I got a response back. Great. How are you? Okay, cool. All right. So that's email. So now we're going to configure FTP, the File Transfer Protocol. And remember that port 20 is the data transfer. Port 21 sets up the connection for us, right? So we're going to configure the server. We're going to do this on the corporate server right here. So we're going to blow this window up a little bit here, give us a little bit more room. We're on services. Let's click on FTP. Okay, so you can see the FTP service is currently off. We're at 90%. I'm going to click the on radio button. It bumps us to 92. In the username box, we're going to put in here student with a capital S. Pay close attention to that because you don't want to lose any points here. And then the password is going to be class. We're going to check every box that exists here. We're going to be able to write, read, delete, rename, and list. Now, once we've got all this set up here, we're going to click on add. Because there was already this user here, Cisco, and they had read, write, delete, rename, and list. So now we've got student, right? Not student 1, not student 2, just student. And it was with the entry of student that we went to 100% on our completion. But let's not cut it short here, right? Let's finish this out and see what we've got going on. So we're going to use the FTP service. Now, this is my FTP server, right? The corporate server. I'm going to jump on PCA. We're going to close down the email because we're not sending email anymore. We're going to pull the command prompt up. And so it's here, right, where if I say dir, it's going to show me the directory that I'm in, which is that C:\\. So, oh, and sorry, let me make sure I got that right. Click on the command prompt, enter dir to see the files on the PC. Yeah, has no label, and that's what we see. And we see sample file.txt. Okay, so I just want to make sure that we're not supposed to see anything other than sample file.txt. So that's what we see. We see that one file, sample file.txt. We're going to put that onto the FTP server. Well, how do we do that? Well, we FTP to 192.168.1.3. The username was student, and the password was class. And here we are, right? So now if I say dir, this is me listing all of the files that are on the FTP server. And you can see tons of iOS images. So let's put our sample file.txt up here onto that TFTP server. And you can see that that worked out great. So we're going to do the dir command again here. And there it is. Again, we're connected to the FTP server. And this is the FTP servers directory. And now the sample file.txt, maybe it's got important notes, who knows, but it's there. So last thing we're going to do is we can put something there. We can list the directory out. Now we're going to get something. So I'm going to say ASA 842, and this is an ancient release of the ASA OS bin for the firewall. So let me make sure I got that right. ASA 842-K8.bin. All right, file transfer is in progress, so we're going to be downloading that. And then we're going to delete sample file.txt. So we'll let this download complete here, and it should not take too terribly long here. And again, they say that you can do the fast forward. So here's the fast forward. If I pull that window back up, whoops, sorry, not B, I want A. If I pull PCA back up and I click on fast forward a few times, when I come back to PCA and I click on it and it's catching up here, oh, the file transfer is still in progress. Oh, I'm sorry. Fast forward time does not help. I missed that part right there. So actually, I just proved to you, fast forward does not help. So we are waiting for this file transfer to complete. Again, we're at 100%. I'm trying to think of anything else. If we were to go look at the switch, actually, I think there was something we wanted to look at here on the switch in, oops, sorry, Cisco. And if I did the show run, it was the transport input lines, right? So why could we not telnet here? Well, it's because the VTY lines have transport input SSH configured. And the login local just means we're using the local AAA database. Now, you might be saying, whoa, wait a minute. I've never heard of it like that. Yeah, so technically, when you are defining your usernames and passwords on the device itself, this is the local AAA database because it's on the system. If we were to be using some kind of a, Cisco Identity Services Engine or something like that, then it's not considered local, right? But again, all that means is we're using the local AAA database or the local user database to get logged in to check usernames and passwords, and we're only allowing SSH. All right, let's drop back over to PCA, and this is taking much longer than anticipated here. Again, we're at 100%. This can take 30 seconds or more to complete. This file is big. So I think we've been waiting longer than 30 seconds. Again, not needed for the lab. We're good to go here. I would love to delete can I Control C? Yeah, there we go. I'm going to Control C out of there. So we're going to go back to FTP. We're going to go back as student, and we're going to go in as class, and we're going to say dir list things out, and we're going to delete sample file.txt. Again, apologize it took a little bit long there. You can see that the file has been deleted. It's now gone. It's not even listed here anymore. And that is a 100% completion of Packet Tracer Activity 5.5.7. All right, there is only one more Packet Tracer activity that's part of Module 5, and we're going to complete that next. As always, thank you guys so much for watching, and I hope to see you in the next video.